Greetings one and all, and welcome to this math video. In this math lesson, we will be considering Bgcse Math 2023 Paper 3. And so we'll be looking at a Bgcse Math 2023 past paper. In particular, we'll be looking at Paper 3, questions that came from Paper 3. And so let's begin. So here we have the cover page of the Bgcse Mathematics 2023 Paper 3 past paper. It says Mathematics, Paper 3, May 24th, 2023, Ministry of Education, National Examinations, Bahamas General Certificate of Secondary Education. And so we'll be considering questions coming from this particular past paper. Let's begin. It says, during a storm, 18 of the boats in the harbor were damaged. This represents 12% of the boats that were in the harbor. Find the number of boats that were in the harbor. And so what we're going to do is we're going to take 12 over 100, 12%. We're going to multiply it by T, where T is equal to the total number of boats that are in the harbor, that were in the harbor, and we're going to set that equal to 18. We have 12 over 100 because we have 12%, and we have T because we say that T is equal to the total number of boats that were in the harbor, and we set that equal to 18 because 18 of the boats in the harbor were damaged. And so we're going to multiply. We have 12 times T, and that gives us 12T. We put it over 100, and we set that equal to 18 over 1. Next, we cross multiply. We say 1 times 12T, and that gives us 12T. And we have 100 times 18, which is 18 times 100. And when we multiply those two, we get 1,800. Next, we divide both sides of this equation by 12. This 12 cancels out with this 12. And so we have that T is equal to 1,800 divided by 12. And so we have that T is equal to 150. And so what does that mean? That means that the number of boats that were in the harbor is 150 boats. Let's move on to the next question. It says that X is directly proportional to T squared. Given that T is equal to 2 when X is equal to 19.6, find the value of X when T is equal to 3. Now it says that X is directly proportional to T squared. What does that mean? Here we use the direct proportion formula. Now, if X is directly proportional to Y, that means, or that implies, that there exists a constant K, such that K times Y is equal to X. So if X is directly proportional to Y, then that means that X is equal to K times Y. In this case, we have that X is directly proportional to T squared, which means that there exists a constant K such that K times T squared is equal to X. But what is this K? What is the value of K? And that's what we're going to determine first. But what we do know is we know that T is equal to 2, and we do know that 19.6 is equal to X. So we substitute. So in place of X, we put 19.6, and in place of T, we put 2. And so what do we have? Well, we have 2 squared, which is 4. And so we have K times 4 is equal to 19.6. And K times 4 is equal to 4K. So we have 19.6 is equal to 4K. Next, we divide both sides of this equation by 4. This cancels with this. And so we have that K is equal to 19.6 divided by 4. Again, K is equal to 19.6 divided by 4. And 19.6 divided by 4 is 4.9. So K is equal to 4.9. Now, since we know that K is equal to 4.9, we're going to substitute that into this equation. So we have X is equal to K times T squared. Now, what is K? Well, K is 4.9. And what is T? Well, T is 3. And so we have 4.9 multiplied by 3 squared. And what is 3 squared? Well, 3 squared is 9. So we have that X is equal to 4.9 multiplied by 9. And 4.9 multiplied by 9 is 44.1. So that means that X is equal to 44.1. Next, we have to figure out the value of T when X is equal to 176.4. Now, we do know that K is equal to 4.9, and we do know that X is equal to 176.4. And so we substitute those values into this equation. Again, K is equal to 176.4, I'm sorry, x is equal to 176.4 and k is equal to 4.9. But we have to figure out what is t, right? And so what do we do? Well, we divide both sides of this equation by 4.9. This cancels out with this, and so we are left with t squared is equal to 176.4 divided by 4.9. Again, t squared is equal to 176.4 divided by 4.9. Now, what is 176.4 divided by 4.9? Well, that gives us 36. And so we have 36 is equal to t squared. Next, we take the square root of both sides. So this root cancels out with this power. And so we have that t is equal to the square root of 36. And the square root of 36 is definitely 6. So t is equal to 6 in this particular question. Next, our goal is to determine, it says matrix A is defined as A is equal to 4, 6, 3, 5. Find the value of the following. A squared. So we have to figure out what is A squared. And so how are we going to figure out what is A squared? Well, A squared is just going to be A multiplied by A. And so what that means is that we're going to take this matrix A and multiply it by itself. That's what we're going to do. We're going to take this matrix A and multiply it by itself. What I'm going to allow you to do is I'm going to allow you to take a moment and attempt this question on your own. And then when we come back, we will do it together. So take a moment, attempt this question, multiply A by A, multiply A by A. So multiply this matrix by itself, and then we'll come back and explain how to do it. Okay, so our goal is to multiply A by A, or to figure out what is A squared. And so in order to do that, the first thing we're going to do is we're going to write the order of the two matrices. So we have matrix A, which is a 2 by 2 matrix, and we have matrix A again, which is a 2 by 2 matrix. And so the first thing we're going to do is we notice that these two are the same numbers. And since these two are the same numbers, that means that it is possible to multiply matrix A by matrix A. Now, what is the order of the resultant matrix? Well, the order of the resultant matrix is 2 by 2. So that means that when we multiply matrix A by itself, the order of the new matrix that is formed is going to be a 2 by 2 matrix. Now, when we say 2 by 2 matrix, what do we mean? Well, we mean that it's going to have 4 entries, right? The first entry is going to be in row 1, column 1. The second entry is going to be in row 2, column 1. The third one is going to be in row 1, column 2. And the fourth one is going to be in row 2, column 2. And so this is going to be the formula we're going to use in order to multiply these two matrices. And so A squared is equal to A times A. And so what we're going to do is we're going to use this formula. The first thing that they tell us is we have to do row 1 multiplied by column 1. And so we're going to take row 1, this is row 1, and we're going to multiply it by column 1. So we have 4 times 4. So we have 4 times 4 here, and we have 6 times 3. So we have 6 times 3. Okay, that's good. Now let's move on to this one. We have, I'm sorry, let's move on to this one. We have row 2, column 2. So we're going to have row 2, I'm sorry, we have row 2, column 1. So we're going to say row 2, column 1. Row 2, column 1. So we're going to say 3 times 4. That's 3 times 4. We're going to say 5 times 3, 5 times 3. Okay. Now we're going to go to row 1, column 2. So row 1, column 2. Again, row 1, column 2. So we have 4 times 6, 4 times 6 here. And then we have 6 times 5, 6 times 5 right here. Then we're going to go to row 2, column 2. And so we have row 2, column 2. So we have 3 times 6, 3 times 6. And we have 5 times 5, which is 5 times 5. Okay, great. Next, we say 4 times 4 is 16. 6 times 3 is 18. Then we have 6 times 4, or 4 times 6 is 24. 6 times 5 is 30. Then we have 3 times 4 is 12. 5 times 3 is 15. Then we have 3 times 6 is 18. And 5 times 5 is 25. Next, we add. We have 16 plus 18. Again, 16 plus 18, we have 34. 24 plus 30 is 54. And then we have 12 plus 15, that's 27. and 18 plus 25 is 43. So we have 34, 54, 27, and 43. So that's what A squared is. A squared is equal to this 2 by 2 matrix. Next, let's move on. Here they want us to figure out what is the inverse of A. So it says matrix A is defined as A is equal to this particular matrix. Find the following. We have to find the inverse of A. Now the inverse of A is going to be equal to 1 over the determinant multiplied by the adjoint. And so what we have to do is we have to figure out what is the determinant, and we have to do 1 over the determinant, and we have to multiply that by the adjoint, okay? Now, so let's first figure out what is the determinant of A. So the determinant of A is given by this formula, AD minus BC. Again, the determinant of A is equal to AD minus BC. What does that mean? That means that we're going to take 4 times 5, and we multiply them by each other. So we have 4 times 5, we multiply them. Then we have 3 times 6, and we multiply them. And then we subtract, right? So we have 4 times 5, we multiply them. 3 times 6, we multiply them, and then we subtract. And so what is 4 times 5? Well, 4 times 5 is 20. And what is 3 times 6? Well, 3 times 6 is 18. So that means that the determinant of A is going to be equal to 20 minus 18, and 20 minus 18 is 2. So the determinant of A is equal to 2. But then we have, so we already figured out the determinant, but we need to figure out what is this adjoint? What does this mean? Well, if we have a matrix, let's say we have matrix A, right? And matrix A is defined as a 2 by 2 matrix that has the entries A, B, C, and D. In order to figure out what is the adjoint, what we have to do is we have to switch A and D. So we have to switch A and D. And that's what we did. We put D here, and we put A here. So we have to switch these two. And then we negate C, and we negate B. And so that's what we do here. We negate C, and we negate B. And that's how we figure out the adjoint. So what do? We switch A and D, then we negate C, and we negate B, okay? And so that's what we do. So the adjoint is going to be, in this case, notice here, we switch 4 and 5. Again, we switch 4 and 5. So we have 5 here, 4 here. And we negate 3, and we negate 6. So we negate 3 here, and we negate 6. So the inverse of A is going to be equal to 1 over the determinant of A multiplied by the adjoint. What is the determinant of A? We just figured that out. The determinant of A is 2. So it's going to be A inverse is going to be equal to 1 over 2, or 1 over the determinant, multiplied by the adjoint. Now, what is a half multiplied by this matrix? Well, we're going to take a half, and we're going to multiply it by each term, or each entry in this matrix. And so we have a half multiplied by 5, which is 5 over 2. And then we have a half multiplied by negative 6, which is negative 6 over 2. And we have a half multiplied by negative 3, which is negative 3 over 2. And we have a half multiplied by 4, which is 4 over 2. And so let's simplify. So we have 5 over 2, 5 over 2. We have negative 6 divided by 2, and negative 6 divided by 2 is negative 3, so we have negative 3. We have negative 3 over 2, which is negative 3 over 2. We have 4 divided by 2, and 4 divided by 2 is simply 2. So A inverse is going to be equal to this particular matrix. Next, we have question 4, which says that the diagram above shows a sector of radius 4 centimeters and area 3 centimeters squared. Using pi as 3.14, show that the angle theta of the sector is equal to 21.5 degrees. So we have to show that this angle theta is equal to 21.5 degrees. Now notice that this right here is a sector of a circle. And so we're going to use the area of a sector of a circle to determine what is the value of theta. And so the formula for the area of a sector of a circle is theta over 360 multiplied by pi r squared. Now what is pi? Well, pi is 3.14. What is r? Well, r is 4. As you can see, the radius right here is 4. And so we have 3.14 multiplied by 4 squared. The area of the circle is 3, so we substitute that as well, because it says right here that the area is 3 centimeters squared. And so what we have 3 is equal to theta over 360 multiplied by 3.14 times 4 squared. Okay, so let me say that again. We have 3 is equal to theta over 360 multiplied by 3.14 times 4 squared. Again, 3, because the area of the circle is 3, is equal to theta over 360 multiplied by 3.14, that's pi, times r squared, which is 4 squared. Okay, so let's multiply. What is 3.14 times 4 squared? Well, that's 50.24. And so we have 50.24 right here. And so we have 3 is equal to theta over 360 multiplied by 50.24. Next, what do? Well, we multiply theta times 50.24, and theta multiplied by 50.24 is 50.24 multiplied by theta, all over 360. And we put the 3 over 1 because we're going to cross multiply. So we say 360 times 3, and we have 1 times 50.24 theta. And so we have 3 times 360 is equal to 1 times 50.24 theta, which equals to 50.24 theta. And so we multiply 3 times 360. 3 times 360 is 1080, and that's equal to 50.24 theta. Next, we divide both sides of this equation by 50.24. And so this cancels with this. And so we have that theta is equal to 1080 divided by 50.24. And when we divide these two, we get that 1080 divided by 50.24 is equal to 21.49681529. That's what theta is equal to. And so what we have here is we can round. So notice that this number here is 9. And once it's 5 or greater, because 9 is greater than 5. So once it's 5 or greater, we round up. And so 9 is greater than 5, so we round up. So that means that we add 1 to 4. And so we have that theta is equal to 21.5 degrees. And that's exactly what we wanted to show, because they tell us that show that theta is equal to 21.5 degrees. And that's exactly what we did. We showed that theta is equal to 21.5 degrees. Correct to 1 decimal place. Next, we have defined arc length D. And so this is the arc length right here. And in order to find out, we're going to use this formula. The arc length is equal to theta over 360 multiplied by 2 pi r, where pi is equal to 3.14, r is equal to 4, and theta is equal to 21.5. And so what we're going to do here is we're going to divide. So we have 21.5 divided by 360, and that gives us 0.0597222222. And we have to multiply that by 2 times 3.14 times 4, and that gives us 25.12. Again, 2 times 3.14 times 4, and that gives us 25.12. And so when we multiply these two together, we get that the arc length is equal to 1.500222222. And how do we get that? We multiply this decimal by this decimal number, and we get 1.500222222. Now we're going to round this correct to 1 decimal place. And notice that this is 0. And so since it's less than 5, we cannot round up. And so 5 remains the same. So we have that D is equal to 1.5 centimeters. And so that means that the arc length D is equal to 1.5 centimeters, correct to 1 decimal place. Next, our goal is to expand and solve this particular quadratic equation. And so the first thing that we're going to do is we're going to distribute. So we have 2x multiplied by x, and then we have 2x multiplied by -6. And so that's what we're going to do. What is 2x multiplied by x? Well, 2x multiplied by x equals to 2x squared. And then we have 2x multiplied by -6, and that gives us -12x. So that's the first thing we did. We distribute 2x multiplied by x gives us 2x squared, and 2x multiplied by -6 gives us -12x. Then we take 12, send it over the equal sign. Sorry, we take 17. We take 17, send it over the equal sign. And so we have 2x squared minus 12x minus 17 is equal to 0. And so what we do here is we can apply the quadratic formula because we have a quadratic equation, all right? And so the general form of a quadratic equation is ax squared plus bx plus c is equal to 0, where a is equal to the coefficient of x squared, b is equal to the coefficient of x, and c is a constant. And so here, a is equal to 2 because the number in front of x squared is 2. b is equal to negative 12 because the number in front of negative 12, b is equal to negative 12 because the number in front of x is negative 12. And c is equal to negative 17. And that's the constant, right? That's c. And so what we're going to do is we're going to substitute. We know that the quadratic formula, based on what we saw, we know that the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac. We put that all over 2a. And so we know what b is, right? B is equal to negative 12. So we substitute. So we have negative 12 here, negative 12 here in placement of b. So we do that to replace b. And we know that 2 is a. So whenever we see a, we put 2. So we put 2 here, and we put 2 here to replace a. And then we have c is equal to negative 17. So whenever we see c, we put negative 17. So we have negative 17 right here. Next, what do we have? Well, we have to evaluate the expression underneath the square root. So we have negative 12 squared minus 4 times 2 multiplied by negative 17. And so what we do here is we evaluate that. And when we evaluate, or when we compute the expression underneath the square root, we get 280. We know that a negative times a negative is a positive. So we just have positive 12. And so we have that x is equal to 12 plus or minus the square root of 280 all over 4. And so notice that this is plus or minus. And so that means that we're going to have a positive x. And that also means that we're going to have a negative x right here. So we have, we're going to have x positive. That's how I should say it. We're going to have x positive, and we're going to have x negative, all right? And so what does x positive mean? Well, x positive means that the sign in between these two terms is a positive. And x negative means that the sign in between these two terms is a negative sign. Now, what does that mean though? That means that we actually gonna have two values for x, right? And so let's determine the first value of x. So first, what is the square root of 280? Well, the square root of 280 is 16.733,20053. And so we have 12 plus this decimal, and we're going to put it all over 4. And so x positive is equal to, when we say 12 plus 16.733,20053, when we add those two, we get 28.733,20053. We put that all over 4. And when we divide these two, we get that x positive is equal to 7.1833,00133. And next, we have to figure out what is x negative. And so what we do here is we take the square root of 280, and the square root of 280 is 16.733,20053. And so we have 12 minus this particular decimal, and we put that all over 4. Next, we subtract. So we subtract this and this, and so we get negative 4.733,20053. So we take this negative, so we take this numerator and we divide it by 4. So we take negative 4.733,20053. We take that and we divide it by 4. And when we divide these two, we get what? We get that x negative is equal to negative 1.1833,00133. But we're not done because we have to write our answer correct to 2 decimal places. And so we looking at this particular number right here, 3. 3 is less than 5, so that means that we cannot round up. So 8 stays the same. So we have that x positive is equal to 7.18. And then we have x negative. Well, we have here 3 here. And so since we have 3 here, 3 is less than 5. And so since we have 3 is less than 5, we cannot round up. So we're just going to have negative 1.18. And we eliminate all of the numbers behind 8. Okay? And so we have two values of x. X is equal to 7.18, and x is equal to negative 1.18. Okay, so next, let's move on. For number 6, they tell us from the diagram above. So from the diagram above, they want us to write an equation for line A. So if we notice here, this is line A, and the equation for line A is going to be x is equal to negative 5, because this is a vertical line that passes through negative 5. And so let's move on. They want us to figure out what is line B. So from the diagram, write an equation for line B. So line B is this particular line, right? This is line B. And the equation for that line is y is equal to 5, because that is a horizontal line that passes through 5 on the y-axis, okay? Moving right along, we have to figure out what is line C. So this is line C. Line C is this slanted one right there. This right here is line C. So we have to figure out an equation for line C. How do we do that? Well, the general equation for a line is equal to y is equal to mx plus b. This is the general form for an equation of a line. This equation, we can express line C in this particular way, all right? And so what we're gonna do is we're gonna figure out, okay, well, what is m and what is b? Okay, that's what we have to figure out. Because this is the general form of an equation of a line, but what we need to do is we need to figure out what is for our particular line, what is m and what is b. So m is the slope, right? And b is the y-intercept. So we have to first figure out what is the slope. So what is the slope of this line? Now, we can figure out what is the slope because we could use this formula. And the formula for the slope is y2 minus y1 all over x2 minus x1. And so that's what we're going to figure out what is m. So m is the slope, so that's the first thing we're going to figure out. So, and that's how we're going to figure out what is the equation for this line. So we first start by trying to figure out the slope of this line. Now, in order to figure out the slope of this line, we're going to use 2 points. So I'm going to use this point. We use any 2 points on the line. I'm choosing to use this point and this point. So I'm using the point 0, -3, and I'm using the point 3, 0. And so what we have here is we have these 2 points. In this case, so for this particular point, we're going to say that x1 is 3 and y1 is 0. x2 is 0 and y2 is -3. And so seeing that we know what is x1, y1, x2, and y2, we can substitute the values. So we know that y2 is -3. We know that y1 is 0. We know that x2 is 0. And we know that x1 is 3. And so we say, what is -3 minus 0? And -3 minus 0 is -3. And 0 minus 3 is -3. So we have that m is equal to -3 all over -3. Now, -3 divided by -3 is going to be equal to 1. So that means that the slope here is definitely 1. So we know what the slope is. Now, what is b? Well, b is the y-intercept. And the y-intercept is the value of y when x is equal to 0. And or we could say that the y-intercept is the point where the line crosses the y-axis. All right, so that's this particular point right there. This is where the line crosses the y-axis at the point 0, -3. And as you can see, x is equal to 0. But what is y? Well, y is equal to -3. And that's what the y-intercept is. It is the value of y when x is equal to 0. And When x is equal to 0, well, y is equal to -3. So we have that b is equal to -3. So we know two things. We know that m is equal to 1. That's the slope is equal to 1. And we know that the y-intercept is equal to -3. And so let's substitute those values. M is equal to 1 and b is equal to -3. So that means that the equation for this line is y is equal to x minus 3. And so that's the equation for the line C, x minus 3. Y is equal to x minus 3. Okay, that's the answer. Y is equal to x minus 3. Moving right along. It says state 3 inequalities that together describe the shaded region above. So we have to use 3 inequalities that together describe the shaded region above. And so let's first start off with this line, y is equal to 5. And so what we notice is that what is y is less than 5? This is very important. What is y is less than 5? Well, y is less than 5. If we were to shade that particular region, we have to think about all of the values that are, okay, so this is 5, right? What are the values that are less than 5? Well, the values that are less than 5 are going to be 4, 3, 2, 1, 0, -1, and so on. So that means that if we were to shade the region, y is less than 5, it will be the region above. It won't be the region above, right? So it would be the region, I'm sorry, it would be the region below this particular line, y is equal to 5, okay? So y is less than 5 is going to be the region below this particular line, y is equal to 5. Because if this is y is equal to 5, then the region below it is going to be y is less than 5. Because these are going to be the numbers that are going to be less than 5. So if we have 5 here, less than 5 would be 4, 3, 2, 1, 0, and so on. So this is the region below. That's why we shaded in green, okay? So y is less than 5. That's the region that we have shaded. It's the region below this particular line. Next, we have to shade the region x is greater than or equal to -5. Now x is greater than or equal to -5. So what is that? Is that going, so this is the line x is equal to -5, line A. Now, are we going to shade to the left of line A or are we going to shade to the right of line A? And remember, it says x is greater than or equal to -5. Where are the numbers that are greater than -5? The numbers that are greater than -5 are -4, -3, -2, 0, 1, 3, 1, 2, 3, 4. So on the right-hand side, it's going to be where x is greater than -5. And so that means that we're going to shade to the right. I'm going to shade to the right of this particular line, all right? Because we want to shade the region x is greater than or equal to -5. And so far we have shaded y is less than 5. That's the green, right? And we have x is greater than or equal to -5, and that's the purple, right? Okay, so what else do we have? We need to determine a test point. And the reason why we're going to determine a test point is because we have to figure out on which side, because notice that we have this particular line. We have this particular line right now. This line that is in yellow. The line y is equal to x minus 3. And so we have to figure out, okay, which side do we shade? Do we shade this side or do we shade this side? And so that's what we're trying to figure out. We don't know which side to shade yet. And so what we have to do is we have to use a test point. And so the test point is going to help us because it's going to tell us where we're going to shade. Are we going to shade on this side of the line or on this side of the line? And so the test point that we're going to use, the point 0, 0. The reason why we use that is because it's easy. It's just 0, 0. And so the point 0, 0 is actually the origin. And so that's this, right? So the reason why we are using this particular point is a test, right? So if when we substitute this particular point into our inequality, and let's say that we get that the answer is true, and if we get that the answer is true, that means that this right here, this side right here is the true side. And if it's the true side, then you shade the true side. Then you shade the true side. But when we substitute the point 0, 0 and we get false, then that means that this point is on the false side, and you don't shade the false side, you shade the true side, then that means that we would shade this side, okay? So it's very much so, everything depends on what we get, either true or false. Again, if we get, so again, this point is on this side, right? If we get true when we substitute our test point into our inequality, if we get true, then that means that this whole side is true, and we could shade the whole side, right? But if we get false, that means that this whole entire side is false, and we must shade this side of the line, all right? And so that's how we test it out. And so you could use any point, but you cannot use any point that's on the line itself. You have to use a point that's not on the line. So 0, 0 is not on the line, so we could use that particular point. And so we're going to substitute that point into this particular inequality. Y is greater than or equal to x minus 3. And so let's substitute that into it. And so when we substitute, we know that y is equal to, oh, and by the way, the test point is the point 0, 0. So this first 0 is x, and the second 0 is y. And so that means that x is 0 and y is 0. And so we substitute y is 0 and x is 0. And so we get that 0 is greater than or equal to 0 minus 3. And 0 is greater than or equal to negative 3. That's what we end up having. Now the question is it true that 0 is greater than or equal to negative 3? And the answer is it is definitely true. So it is definitely true that 0 is greater than or equal to negative 3. And so that means that the point 0, 0 is on the true side. And so since the point 0, 0 is on the true side, that means that the whole side here is true, because this point tests true on this inequality. So that means that this whole side on this side is the true side, and we always shade the true side. And so that means that we're going to shade this particular side, all the side, right? Because that's the true side, okay? That's the true side. Okay, so what do we have so far? Well, we have this particular region. We have, let me use a yellow. So we have this particular region right here. This is the region where all the lines intersect. The purple line, the green line, and the brown line, right? All of them intersect right here, right? That's where all of them intersect. This is the portion where all of them intersect, right? Right here, which is the shaded portion that was already shaded for us, okay? And so what does that mean? That means that the three inequalities that we have can be used to describe this particular shaded region, because all three of those lines intersect right at this particular region. So we have the purple one intersect here, we have the brown one intersect here, and we have the green one intersect here. So this right here is, that means that we could use those three inequalities to describe the shaded region, okay? And so all this right here is where these three colors intersect, right? And so that means that we could use these three inequalities to describe the shaded region. And so we use y is greater than -5. We use x is greater than or equal to -5. And we have that y is greater than or equal to y is greater than or equal to x minus 3. So the three inequalities that together describe the shaded region is y is less than 5, x is greater than or equal to -5, and y is greater than or equal to x minus 3. Okay, so let's move on. Here we have to factorize this particular expression. We have 12x cubed minus 75x. Notice that we have 12 here and we have 75 here. And so we ask ourselves, what is the highest number that can go into both 12 and 75 without leaving a remainder? In other words, what is the highest common factor of 12 and 75? And the answer is 3, because 3 can go into both 12 and 75. And then we look and we see that x is here and x is here. So x is a common factor of this particular term and this particular term. And so we factor out a 3 and we also factor out an x. And when we factor out 3x, we are left with 4x squared minus 25. And we know that we are left with that because if we multiply this expression, 3x, by this, we get exactly the expression above. And so let's try that. We have 3 times 4, which gives us 12, and x times x squared is x cubed. And then we have 3 times 25, 3 times negative 25, and 3 times negative 25 is negative 75. And we have the x here. That's why we have the x here, and we also have the x here. And so we have 3x multiplied by this particular expression gives us this expression above. Indeed, the expression below is the factored form of the expression on top. Okay, so we are done with factorizing this. Well, notice, I noticed something that, I noticed that we could use the difference of 2 squares. It just occurred to me. I just noticed that we could use the difference of 2 squares for this particular one. Okay, so wait, we're not done. We're not done with factorizing this. We could actually factorize this some more because we could use the difference of 2 squares formula. Now, wow, I didn't even see that before. Okay, so the difference of 2 squares. So let me show you what the difference of 2 squares. The formula says that if you have a squared, right, minus b squared, that's going to be equal to a plus b multiplied by a minus b. A minus b. And so what does that mean? That means that with the difference of 2 squares formula, this is it right here. That means that a squared minus b squared is equal to a plus b multiplied by a minus b. So what does that mean? That means that what you have to do is you have to take the square root of a squared. So you have to take the square root of a squared, which is a, and take the square root of b squared, which is b. And then you add them, then you subtract them. And so that's what we're going to do. So we're going to take the square root of 4x squared. So what is the square root of 4x squared? Well, the square root of 4x squared is going to be equal to, what's the square root of 4? The square root of 4 is 2, because 2 times 2 is 4. What's the square root of x squared? Well, the square root of x squared is x, okay? So that means that the square root of 4x squared is 2x, because the square root of 4 is 2, and the square root of x squared is, well, this cancels with that, it's x, okay? So that means that the square root of 4x squared is equal to 2x. Next, we have to take the square root of 25. What's the square root of 25? Well, the square root of 25 is equal to 5, because 5 times 5 is 25. And so remember, what does the difference of 2 squares formula says? It says take the square root of a squared, take the square root of b squared, and then add them and subtract them. And so that's what we're going to do. So we're going to say that this is equal to, this is equal to 3x, open bracket, 2x plus 5, close bracket, and 2x minus 5. All right. And so now this is in factored form. All right. So our final answer is 3x multiplied by 2x plus 5 multiplied by 2x minus 5. Next, we have to determine, or we have to factorize this particular algebraic expression. So we have 3ay minus by minus 6a plus 2b. We're going to factorize this particular expression first. Then we're going to factorize this expression. And so what do we have? Well, this term has y in it, and this term has y in it, which means that y is a common factor of these two terms. So when we factor out a y, when we factor out a y, we are left with 3a minus b. And that makes sense because y times 3a is 3ay, and y times negative b is negative by. And so this right here at the bottom is the factored form of the expression on top. Next, we have negative 6a plus 2b. And in this case, we factor out a negative 2 because negative 2 multiplied by 3a gives us negative 6a. And then negative 2 multiplied by negative b is equal to positive 2b because negative times a negative is a positive. And so we factor out a 2 in this case. And we are left with 3a minus b. Now notice that here we have 3a minus b. And here we have 3a minus b, which means that 3a minus b is a common factor of these two terms. And so that means that we have 3a minus b. So that means that what we're going to do is we're going to factor out, since 3a minus b is a common factor of both of these terms, we're going to factor out 3a minus b and see what we're left with. So when we factor out 3a minus b, we are left with y minus 2. And so our answer here is 3a minus b multiplied by y minus 2. And that's the answer for this question. Next, our goal is to factorize and simplify. So we have 2x squared plus 5x minus 12. Again, we have 2x squared plus 5x minus 12. And that is the bottom because we are going to first factorize the denominator. And so let's do that. So what we're going to do is we're going to figure out two numbers that when we add them, we get 5, which is the coefficient of x, right? And then when we multiply them, we get what is 2 times negative 12. Well, 2 times negative 12 is negative 24. So we're going to find two numbers. When we add them, we get 5. But when we multiply them, we get 2 times negative 12, which is negative 24. And so the two numbers that we're going to use is 8 and negative 3, because 8 plus negative 3 is positive 5, and 8 times negative 3 is negative 24. And so what do we have? We have that 2x squared plus 8x minus 3x minus 12. So what do we do? Well, I express 5x as 8x minus 3x, because 8x minus 3x is simply 5x. And so what are we going to do here? Well, we're going to factor out these two terms and factor out these two terms. And so what do we have? Well, we have that 2 is a common factor of these two terms. We have that x is a common factor of these two terms. And so we have 2x multiplied by x, which is 2x squared. And we have 2x multiplied by 4, which is 8x. And then we have negative 3 multiplied by x, which is negative 3x. And we have negative 3 multiplied by 4, which is negative 12. So in this case, we factored out we factored out negative 3. And in this case, we factored out 2x. When we factored out 2x, we are left with x plus 4. When we factor out negative 3, we are left with x plus 4. Because negative 3 times x is negative 3x, and negative 3 times 4 is negative 12. And so notice that we have x plus 4 in this term, and we have x plus 4 in this term. And so that means that x plus 4 is a common factor of both of these terms. And so we factor out x plus 4. When we factor out x plus 4, what are we left with? Well, we are left with 2x minus 3. That's 2x minus 3. And so that is the factored form of the expression in the denominator. And so let's write that down. So we have 2x minus 3 all over 2x squared plus 5x minus 12. Remember what our denominator is equal to. Our denominator expressed in factored form is x plus 4 multiplied by 2x minus 3. And so what we can do here is we can cancel out. And so this 2x minus 3 cancels out with this 2x minus 3. And so we're left with 1 over x plus 4. And that's our answer to this question, 1 over x plus 4. Next, we have this probability question. And it says that the probability Adrian has breakfast, we call that B, is 2 over 5. If he has breakfast, the probability that he arrives at work in time is T, and T is 2 over 7. If he does not have breakfast, and B, the probability that he arrives at work late is 3 over 7. Copy and complete the tree diagram below using the above information. And so the probability that Adrian has breakfast is 2 over 5. So the probability that he has breakfast is 2 over 5. And the probability that if he have breakfast, he arrives to work on time is going to be 2 over 7. So 2 over 7 is the probability that, so 2 over 7 is, notice what it says, the probability that if he has breakfast, so if he has breakfast, the probability that he arrives on time is 2 over 7. So if he has breakfast, right, the probability of him arriving to work on time is going to be 2 over 7. And so what we have to do is we have to copy and complete this Venn diagram. We have to complete this tree diagram. And so we have this space missing, we have this space missing, we have this space missing. And so we have to finish this, diagram. Now, they said here that the probability that Adrian has breakfast is 2 over 5. And so what we need to figure out is what is the probability that he does not have breakfast, right? Now, the good thing is that since we already know that probability that he has breakfast is 2 over 5, that means that the probability that he does not have breakfast is going to be 3 over 5. And the reason for that is because these two probabilities must be equal to 1. And 2 over 5 plus 3 over 5 is equal to 5 over 5, which is equal to 1. And so since this is 2 over 5, you automatically can know that this is 3 over 5 because they have to add up to equal to 1. And so they give us a good hint because they tell us that this is 2 over 5. And so all we need to do is say, okay, well, this is going to be 3 over 5 because 3 over 5 plus 2 over 5 is 5 over 5, which is 1. The same thing is true here. So they want us to figure out what is this? Well, we already know that this one is 2 over 7. And we know that this one, these two probabilities must equal to 1. So if this is 2 over 7, then this one must be 5 over 7. Because 2 over 7 plus 5 over 7 is 7 over 7, which is 1. Again, these two probabilities must be equal to 1. The same thing is true here, right? They give us a good hint because here they tell us that this probability is 3 over 7. But if this probability is 3 over 7, and the two probabilities must add up to give us 1, then this here must be equal to 4 over 7. So 4 over 7 plus 3 over 7 is equal to 7 over 7, and 7 over 7 is 1. And so here we have completed the tree diagram. Next, it says find the probability that Adrian has breakfast and arrives at work in time. So the probability that Adrian has breakfast and arrives at work in time. So we have to first consider this one, and then we have to consider this one. So the probability that he has breakfast is 2 over 5. And if he has breakfast, the probability that he arrives to work on time is 2 over 7. So we put 2 over 7, and then we multiply it. And we multiply it because it says and. Has breakfast and arrives to work on time. So we use multiplication because they tell us and. Now they said, so we have 2 over 5 multiplied by 2 over 7. And so we have 2 times 2, which is 4, and 5 times 7, which is 35. And so it's going to be 4 over 7. So the probability that he has breakfast and arrives at work in time is 4 over 35. Next, it says the probability that Adrian arrives at work late. So find the probability that Adrian arrives at work late. So there's different ways that this could happen, right? So let's explore the possibilities. So he could have breakfast, and the probability of that is 2 over 5, and then he could arrive to work late. That's a possibility. So we could have breakfast and then arrive late, all right? Or he could not have breakfast and still arrive late, right? So there are two ways that this could happen. And so let's figure out what is the probability that he eat breakfast and arrives late. So eat breakfast and arrives late. So that means that the probability that he eat breakfast is 2/5. So we put 2/5 here. And arrives late. So if he has breakfast, the probability that he arrives late is going to be 5/7. And so we have 2/5 multiplied by 5/7. But there's another way that it could happen. He could have no breakfast and still arrive late. So what's the probability that he has no breakfast? That's 3/5. So what's the probability that so the probability that he has no breakfast is 3/5. But if he has no breakfast, what's the probability that he arrives late? Well, that's going to be 3/7. And so we have 3/5 multiplied by 3/7. And since it's two ways it can happen in this way or the next way. So we use addition because it's or. This way or the next. And so let's multiply these things out. So 2 times 5 is going to be 10. 5 times 7 is 35. 3 times 3 is 9. And 5 times 7 is 35. And we add these two. 10 plus 9 is 19. So we have 19/35. And that's our answer. Okay, so let's move on to the sets question. It says a group of 110 students of grade 12 were asked which sports they played. The results are below. F is the students who play football, B is the students who play basketball, and S is the students who play softball. It says 14 students play football only, 11 students play softball only, 15 students play football and basketball only, 21 students play all three sports, 13 students play none of these sports, X students play football and softball only, 2X students play basketball and softball only, 3X students play basketball only. And what they want us to do is they want us to copy and complete the Venn diagram using the information above. And so what we're going to do is we're going to complete this Venn diagram. The first thing that we notice is that 13 is on the outside. Now, why is 13 on the outside? Because if they said 13 students play none of these sports, so 13 is on the outside. The second thing we notice is that 11 is here, and 11 is here because 11 students play softball only. And this right here is softball only, and so we have 11 here. Next, it says 15 students play football and basketball only. And so football and basketball only is right here. That's represented by this part of the diagram. So we put 15. And it says that X students play football and softball only. And so football and softball only is going to be right here. And so we have to figure out the rest. So we have that 21 students play all three sports. So since 21 students play all three sports, we're going to put 21 in the middle. And then the next one, it says 14 students play football only. So 14 students play football only. So we put 14 right there because 14 students play football only. And then what else do we have? They tell us that 3X students play basketball only. So we put 3X right there. And then they tell us that 2X students play basketball and softball only. And basketball and softball only is right here. And so here we completed the Venn diagram and in terms of X, right? And so what else do they want us to do? They want us to form an equation and solve it to find the value of X. And so in order to do this, what we're going to do, notice that we have our Venn diagram. And so what we're going to do is we're going to form this equation. What does the equation say? Well, first of all, let's go back and determine how many students inside this group. So it's a group of 110 students. So please bear that in mind. It's a group of 110 students all together. So that's why we're going to set this equal to 110. So we have 14 plus 15 plus 3X plus X plus 21 plus 2X plus 11 plus 13. All of that should be equal to 110. And so we group our like terms. We put all of the numbers together, and we put all of the terms that have X in them together. And so when we add them, we get 14 plus 15 plus 21 plus 11 plus 13 is 74. We bring back 3x plus 2x. And then what we say here is, okay, what is 3x plus 2x? That's going to be 6x. So we have 74 plus 6x is equal to 110. What we're going to do here is we're going to take the 74, send over the equal sign. And so we have 6x is equal to 110 minus 100. We have that 6x is equal to 110 minus 74. And what is 110 minus 74? Well, 110 minus 74 is going to be 36. And so what do we have? Well, we have that 6x is equal to 36. Okay, so what we're going to do here is we're going to divide both sides of this equation by 6. So this 6 cancels with this 6. And so we are left with x is equal to 36 divided by 6. And 36 divided by 6 is definitely 6. So x is equal to 6. Good, so x is equal to 6. And so we formed an equation and we solved it for x. Good, let's move on. What we're gonna do here now, since we know that x is equal to 6, we're gonna figure out what is 3x, what is 2x, what is x, so that we can have numbers inside of this Venn diagram. That will be useful, especially for the next parts of this question. So we know that x is 6. We know that 3x is going to be 3 times x, which is 3 times 6, which is 18. We know that 2x is going to be 2 times 6. 2 times 6 is 12. And so we have that x is equal to 6. 3x is equal to 18. 2x is equal to 12. And so let's put those values into our equation. Into our Venn diagram. So x is equal to 6. This is 18. This is 12. So all we have here, so what we have here is the numbers, and that's going to be useful, especially when answering these questions. Okay, so let's move on. It says find the number of students who play basketball. So the number of students who play basketball is, we can find that by adding all of the numbers inside of this set, because this whole set is the basketball set. And so that means that we have to add 21 plus 15 plus 18 plus 12. When we add all of them together, we get 66. And so the number of students who play basketball is going to be equal to 66. Next, we want to find the number of students. It's students, right? Yes, the number of students that are in basketball intersect softball. So we want to figure out the number of elements in B intersect S. All right, the number of elements in B intersect S. So what is B intersect S? Well, B intersect S, let me shade that region. So B intersect S is going to be this right here. Oh, let me use a different color. So let's use this yellow. So B intersect S is going to be this particular portion, right? That's B intersect S. And this is these two, right? 21 and 12. This is going to be B intersect S, right? So that's how we're going to figure out the number of students who are in B intersect S. We're just going to add 21 and 12. And 21 plus 12 is what? 21 plus 12 is definitely 33. And so that means that the number of students in basketball and softball is going to be 33. And so B intersect S is going to be 33. Okay, so let's move on from that. Next, we have to figure out the number of elements in F complement. Now, what is F complement? Well, F complement means that we want all of the elements in the universal set, except for the elements that are in F. So we do not include, I repeat, we do not include any of the elements that are in F. Okay, so do not include any of the elements, any of the numbers that are inside of this circle F, right? Do not include them. But we can include any other number that is inside the universal set. So we can include 18, 12, 11, 13. Those are all fine, but we cannot include 14, 15, 21, and 6. And so that means that the number of elements in F complement is going to be 18 plus 12 plus 11 plus 13. Again, 18 plus 12 plus 11 plus 13. and that gives us 54. So that means that the answer here is definitely 54. Now for this one, we want to figure out the number of elements in S complement intersect F union B. So S complement intersect F union B. First of all, what is the number of elements in F union B? Well, what is F union B? Well, F union B, if I were to show you this on the Venn diagram, F union B is all of this. So all of this is F union B. So all of the elements in F union B, right? So this is the shaded part for F union B. So the number of elements in F union B is going to be what? Well, it's going to be 14, 15, 18, 6, 21, and 12. That's what we have, F union B. Now we want to figure out the number of elements in S complement. Now what is S complement? Well, S complement is going to be all of the elements in the universal set, all of them, all of the elements, every last one of those elements in the universal set, right? Except for the elements that are inside S. So all of these numbers that are in the universal set, all of them, right? Except for the elements that are inside of S, okay? And so what that means is, that means that we do not include any of the elements that are inside of this circle. Do not include any of the numbers inside the circle, okay? So we do not include 6, we do not include 21, we do not include 12, we do not include 11 because they are inside S. We want S complement. So that means that we can have 14, 15, 18, and 13. And so now that we know what's the number of elements in F union B and the number of elements in S complement, what we're going to do is we have to find the intersection of these two sets. And so we have this, these two are the same, these two are the same, and these two are the same. And so that means that the number of elements in S complement intersect F union B is going to be 14, 15, and 18. And 14, 15, and 18 added together, that's 14 plus 15 plus 18, that gives us 47. And that's the answer to this question. Next, it says that the diagram shows a solid half cylinder of diameter 20 centimeters and length 35 centimeters. Again, the diagram shows a solid half cylinder of diameter 20 centimeters and length 35 centimeters. Calculate the total surface area of the half cylinder. Now, surface area just means that we're gonna add up all the areas. We're gonna first determine the areas of the portions of the shape, and then we're gonna add them all together. And so let's first label this. So we have A, B, base, and C, okay? So let's first figure out what is the area of the base. Now the base this is a rectangular base. And so we're gonna use length times width. And so we have 20 centimeters multiplied by 35 centimeters. And so the area of the base is going to be 20 centimeters multiplied by 35 centimeters, which gives us, well, that gives us 700 squared. 700 centimeters squared. That's the area of the base. 20 times 35 is 700. So the area of the base is 20 centimeters times 35 centimeters is 700 centimeters squared. And so the area of the base is 700 centimeters squared. Next, we have to determine what is the area of A. And this right here is a semicircle. We're going to use the formula for a semicircle. And so the formula for the area of a semicircle is pi r squared divided by 2, where pi is, in this case, equal to, well, they didn't tell us what pi is equal to. Okay, so we're just going to leave it as pi. Okay, so, but what is r? R is going to be equal to, well, r is 20 divided by 2. And the reason why we have r is 20 divided by 2 is because the diameter is 20 and the radius is half of the diameter. So if the diameter is 20, then the radius must be 10 because 20 divided by 2 is 10. So we have pi r, which is 10, squared all over 2. So pi r squared. Yes, pi r squared. So pi multiplied by r, which is 10. So this is 10 squared all over 2. So pi r squared, because 10 is r, all over 2. Next, what do we have? What is r squared, or what is 10 squared? Well, 10 squared is 100. So we have pi times 100 over 2, and that's going to give us 100 pi over 2. And 100 divided by 2 is definitely 50. Again, 100 divided by 2 is 50, so we have 50 pi. So the area of A is going to be 50 pi. Next, we need to figure out what is the area of B. But the area of B is also a semicircle, okay, with the same diameter. And so that means that we can use the formula pi r squared all over 2. And we know what r is. R is still 10 because it's the same diameter and hence the same radius. So it's going to be pi times 10 squared all over 2. So we have 10 squared, which is 100. So we have 100 times pi all over 2. And 100 times pi is 100 pi. So we have 100 pi all over 2. And 100 pi all over 2 is going to be 50 pi. Okay. And so the area of A is going to be 50 pi. The area of B is going to be 50 pi as well. Next, we have the area of C. And so the area of C, well, notice that they said that this is a half cylinder. And so since it's a half cylinder, if we're looking at this carefully, what we have to do is, no. In order to figure out, let me explain this properly. In order to figure out the area of C, you have to do length times width. And the reason why we're doing length times width, because this particular shape, the shape of this particular part of this solid is actually a rectangle, okay? Where we have that the length is equal to 35, and we have that the width is equal to pi r squared. And so the area of C, which is this particular, let me show you it clearly so you can understand what I'm talking about. So what the part we're actually trying to figure out is we're trying to figure out this particular, let me show you the shape that we're trying to find the area of so you can understand what's happening. So we have this particular shape here, okay? And so this particular shape is what we have. Now, this particular shape is actually, we could actually, if we were to lay it flat, it's actually a rectangle, right? It's actually a rectangle. Now, what is the length of this rectangle? Well, the length of this rectangle is going to be, so we have the length and the width. So one side of this rectangle that we have here is going to be equal to what? 35 centimeters squared. 35 centimeters. And we have to figure out like, what is this side, right? What is this side? Okay, and that's what we have to do. So this, we already know what this is. This is 35 centimeters. We already know that that's 35 centimeters. We already know that if this is 35, this is also 35. But what is this? What is this particular length right there? And what is this particular length? Because this particular length is actually the curved portion, right? The curved portion of the semicircle, right? That's literally what that length is, right? But this particular length is the curved portion of the semicircle. And so that's why that this particular length, we're gonna call it pi r squared. And the reason why we have it as pi r squared, because that is, so it's gonna be pi, right? Pi r squared. And so we have 35 multiplied by pi r squared. But I still don't think that pi r squared is the right thing. What I'm gonna do, I'm gonna pause this video and then I'm going to redo this question so that we can get more clarity on this. Okay, so I realized that I definitely made a mistake in explaining this particular portion, part C, the area of C. So I'm going to start it again. Let me erase everything here. I'm going to start it again, and then we're going to explain. I'm going to explain how to actually get C. All right, and so that's what I'm going to do. So let me erase all of this, move this out the way, and then let's go ahead and explain this again. with the correct explanation of part C. So let's do this again. So they want us to find the surface area of the half cylinder. It says the diagram shows a solid half cylinder of diameter of 20 centimeters and length 35 centimeters. And so that's what we have that in the diagram. And they want us to calculate the total surface area of the half cylinder. So in order for us to figure out the total surface area, we're going to do the area of each particular part, and then we're going to add them together. So the area of A is going to be, the area of the base. So we start off with the area of the base, which is going to be equal to, we're going to take the two sides and we're going to multiply them by each other. The length is 35 and the width is 20 centimeters. So area of a rectangle is going to be length times width, which is 35 centimeters multiplied by 20 centimeters, and that gives us 700 centimeters squared. That's the area of the base. Now we have to figure out the area of A. Now A is a semicircle, so we're gonna do pi r squared divided by 2, where r is the radius, which is half of 20, and half of 20 is going to be 20 divided by 2, which is 10, and so the radius is going to be 10. So we have pi r squared all over 2, or pi 10 squared all over 2. We know that 10 squared is 100, so we have 100 times pi is equal to 100 pi, and so we have 100 pi all over 2, and 100 pi all over 2 is equal to 50 pi. The same thing is for the area of B. So the area of B is the same semicircle. So we're going to use pi r squared divided by 2, where r is equal to 10 centimeters, because 10 is the radius, because it's half of 20, half of the diameter. And so we have pi times 10 squared all over 2. 10 squared is going to be 100. So we have 100 times pi all over 2, and 100 times pi is 100 pi, and we divide that by 2. And so we have 100 divided by 2, and 100 divided by 2 is 50. So we have that the area of B is equal to 50 pi. Next, we have to determine what is the area of C. And this is what we were on. And so if we look at C, well, let me first highlight what is C, right? So let's highlight it first. So C is going to be this particular shape, all right? All right, this is C. C is going to be this particular shape that we have, right? This is C, all right? All right, this is C. So if we were to map this out, right? We would find that we would have mapped this out. We would find that this particular side, all right? So let me use this particular side. This particular side right here, this is going to be, this length is this length is the length of the curved portion of a semicircle. So this length is the curved portion of a semicircle. The same thing with this one. This length is the curved portion of a semicircle. All right. So what is the formula for the curved portion of a semicircle? Well, we could use this one, pi d. Okay. And so that's what we have to use. But it's the curved portion of a semicircle. And so if we have so for example, we have this one right now. So if we have this semicircle right now, so this right now is a semicircle. We do not include this particular portion. We just want the curved portion. So if we want the curved portion of the semicircle, let me use a highlight. We just want, what we're trying to focus on is the curved portion of the semicircle. All right. That's all we're trying to figure out. What's the curved portion of a semicircle? Now, if we look at this particular diagram right now, this is like the full cylinder, all right? And if we were trying to figure out like the length of the curved portion of the full cylinder, like all the way around, it's going to be pi d, okay? It's going to be pi d. But we just want the curved portion of a semicircle. So it's not going to be pi d, all right? What is it going to be? Well, it's going to be this length, the length for the curved portion is going to be pi d, right? Divided by what? Divided by 2, okay? And so that means that this particular length right here is what? Pi d divided by 2, okay? And then this length also is So this length is pi d divided by 2. And then this length is also pi d divided by 2. Okay, pi d divided by 2. And then we have this right here is going to be 35, right? Because this is 35. And this right here is going to be 35. Okay, so given that you already know the dimensions of this rectangle, what I want you to do is I want you to determine the area of C. We already know what this one is, we already know what this one is. Solve it and determine the area of C, and let me see what you get. And then I'll come back and explain it. Okay, so here we have the area of C, and the area of C is going to be length times width. Now, what is the length? The length in this case is 35, all right? So that's the length. So the length is 35. And what is the width? Well, the width is pi d over 2. And why is it pi d over 2? Because this length right here is the length of the curved portion of a semicircle, which is given by the formula pi d over 2. Because we're looking at the curved portion of a semicircle. Now, if we was looking at the curved portion of the full circle, then we're going to have pi d, like if we were looking at the curved portion of the full circle. We're just looking at the curved portion of half of, right, the circle. So it's going to be pi d all over 2. And so, because it's half of it. So this particular length right here is pi d over 2. And the same thing with this one. This is pi d over 2. And so the area of C is going to be length times width. So it's going to be 35, which is this. We got that from here. 35 multiplied by pi d over 2. So 35 multiplied by pi d over 2. What is d? Well, d is the diameter. The diameter is 20. So we have 35 multiplied by pi times 20 over 2. And then we have 20 divided by 2, which is 10. So we have 35 times 10 pi. Again, we have 35 times 10 pi. And 35 times 10 pi is 350 pi. And so the total surface area is going to be the area of the base, which is 700, the area of A, which is 50 pi, the area of B, which is 50 pi, and the area of C, which is 350 pi. Next, we notice that all three of these terms have pi in it, so we factor out the pi. And so when we factor out the pi, we are left with 50 plus 350. And so that gives us 450 pi. So 50 pi plus 50 pi plus 350 pi is 450 pi. And we cannot forget the 700. The 700 was right there. So we have 700 plus 450 pi. And so when we do the calculation, they didn't tell us exactly what pi is in this particular one. Usually they just tell us that pi is 3.14 or pi is 22 over 7 or something like that. But in this case, they didn't tell us what pi is. So we're just going to use the pi that is on our calculator. So just write inside your calculator 700 plus 450 pi, like the actual pi sign. Hopefully your calculator has it. My calculator has it. So I just have to put in 700 plus 450 pi, and that gives us 2,113. That's 2,113.716694 centimeters squared. And if we were to round this correct to 2 decimal places, so let me round this correct to 2 decimal places because I didn't do that. That gives us, it's going to be equal to 2,113.72 centimeters squared. And the reason why it's 0.72 is because this number is 6, and so it's greater than 5, so we round up. So it's going to be 2,113.72 centimeters squared, and that's the answer to this particular question. Moving right along, we have that the half cylinder, which we just saw, is glued to a cuboid of a length 35 centimeters, width 20 centimeters, and height 12 centimeters as shown below. Calculate the total volume of the solid form. And so for this one, we just have to figure out the volume of the half cylinder, and we have to figure out the volume of the cuboid, and we add them together. And so the volume of a half cylinder is going to be pi r squared times h all over 2 because it's half cylinder. And here we know that r is going to be 20 divided by 2, which is 10. So r is 10. So we have pi times 10 squared, right? But what is h? H is the height or length, and that's going to be 35, right? And so, because this also has 35, okay? And so we have pi times 10 squared times 35 all over 2. And then we have that 10 squared times 35 is going to be 3,500. So we have pi times 3,500 all over 2. And so that means that the volume of the half cylinder is 3,500 pi all over 2. And 3,500 pi all over 2 is definitely 1,750 pi. That's the volume of the half cylinder. But we're not done because we need to figure out the volume of the cuboid. And the volume of the cuboid is going to be length times width times height, where the length is 35 centimeters, the width is 20 centimeters, and the height is 12 centimeters. And so that's going to be 8,400 centimeters cubed. Again, that's 8,400 centimeters cubed. And if we want to figure out the total volume of the solid, we say 1,750 pi plus 8,400, and that gives us 5,497.787144. That's because that's what 1,750 pi is equal to. So 1,750 pi is equal to 5,497.787144. And we have to add that to 8,400. And when we add them together, we get 13,897.78714 centimeters cubed. So that means that the volume, the total volume of the solid is 13,897.78714 centimeters cubed. Next, this question says that AB is parallel to ED. AB is equal to 245 centimeters. AC is equal to 168 centimeters. BC is equal to 92 centimeters, and CD is equal to 72 centimeters. Find the size of angle ACB. So we need to figure out what is the size of angle ACB. So what they really want us to figure out is the size of this particular angle. What is the size of it? And now in order to do this, what we're going to do, first thing we're going to label our triangle, and we're going to label it in light of the cosine rule. So the cosine rule for finding the missing angle is cosine of A. Cosine of capital A is equal to B squared plus C squared minus A squared all over 2BC. In this case, capital A is the missing angle, and the side that is opposite the missing angle is small a, which is 245. And then we have the other sides of the triangle is going to be B and C, where B is equal to 168 centimeters and C is equal to 92 centimeters. And so we substitute, we know that small b is 168, small c is 92, small a is 245, b is equal to 168, and c is equal to 92. And so we need to figure out what is a. Now we compute, we say that 168 squared plus 92 squared minus 245 squared is equal to negative 23,300, and it's equal to, 168 squared plus 92 squared minus 245 squared gives us negative 23,337. And then we have 2 times 168 times 92. That gives us 30,912. And when we divide these two, we get negative 0.7549495534. Next, we take the cosine inverse of both sides because this cancel with this, and we are just left with A. A is equal to cosine inverse of negative 0.7549495534. And so we take the cosine inverse of this particular decimal. And when we do that, we get that A is equal to 139.02096004. And so if we were to write this corrected to 2 decimal places, we'll have that A is equal to 139.02 degrees. And that's the size of angle ACB, correct to 2 decimal places. 139.02 degrees. Next, they want us to find the area of triangle ABC. And for that one, we're going to use this particular formula. The area is equal to a half AB multiplied by sine C. Now in this case, A is equal to 92 centimeters. B is equal to 168 centimeters. And C is equal to this same missing angle, 139.02, right? Which we found, 139.02. And so what we have here is a half multiplied by 92 multiplied by 168 multiplied by sine of 139.02. And so what do we have, right? We have half times 92 times 168, and that gives us 7,728 multiplied by sine of 139.02. What we do here is we multiply these two. When we multiply these two, and we multiply 7,728 by sine of 139.02, we get 5,067.987977. Next, what we do is we look at this particular number. This is 7. It's greater than 5, so we round up. So that means that we add 1 to 8, and that's 9. So it's 5,067.99 centimeters squared. That's the area of this triangle. Two decimal places. Next, it says state in correct order the triangle that is similar to triangle ABC. So we have to state it in correct order, the triangle that is similar to triangle ABC. So notice that this triangle and this triangle, these two triangles are similar. And so if we were to take this particular triangle and if we were to turn it, we'll see that this C corresponds with this C, this D corresponds with this A, and this E corresponds with this B. So A corresponds with D, like we have it, A corresponds with D. E corresponds with B, E corresponds with B, and C is C. So it's going to be DEC. That's the incorrect order of the triangle that is similar to triangle ABC. Okay, let's move on. Here it says hence or otherwise find the length of DE. So we need to figure out what is DE. The first thing we need to figure out is we need to figure out the scale factor, because since we know that both of these triangles are similar, or since we know that these triangles are similar triangles, that means that there exists a scale factor that we could use to find the length of DE. And so the scale factor can be, the formula for the scale factor is new length divided by old length. So in this case, the new length is 72, the old length is 168. We divide those two and we get, well, we reduce it. So we have 72 divided by 8, which gives us 9, and 168 divided by 8, which gives us 21. We still could reduce this fraction, so we divide both sides, both top and bottom, by 3. So we have 9 divided by 3 and 21 divided by 3, so it's going to be 3 over 7. So the scale factor is 3 over 7. And what we want to find is we want to find DE. So DE is definitely here and here. And so what we need to do is we realize that DE, right, this same DE, right, corresponds with BA or AB, right? So that means that we could in answering the question, we could use the scale factor and multiply it by 3, 4, 5, and that should give us what DE is, okay? So the DE is going to be 3 over 7, the scale factor, multiplied by 2, 4, 5, right? That's 3 over 7 multiplied by 2, 4, 5. That's what DE is going to be equal to. 3 over 7 multiplied by 2, 4, 5. And that means that DE is equal to 105. So DE is equal to 105 because we took 3 over 7 and we multiplied by 3, 4, 5. I'm sorry, we take 3 over 7 and we multiply it by 2, 4, 5. And that gives us 105. Okay, here we have the functions question. it says that the functions f and g are defined as follows. F such that, so we have function f, and function f says that we have the smallest prime number that is greater than x, and function g says x plus 1 all over 3. So what is function f really saying? Well, function f is saying that the outputs of this particular function is going to be the smallest prime number that is greater than its input. So the output is going to be equal to the smallest prime number that is greater than its input. So the output is going to be the smallest prime number that is greater than x. So if we have f of 20, what the question is basically asking us for is, okay, can you tell me what is the smallest prime number that is greater than 20? And if you can tell me the smallest prime number that is greater than 20, then that would be f of 20. That would be the output, okay? And so let's list the prime numbers that we have. Prime numbers that we have are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, and the list goes on. So there are more prime numbers, but those are the ones that I list here. And so what this question is asking us for is, hey, I want you to tell me what is the smallest prime number that is greater than 20. And so if we look at this, if we try 17, well, 17 is not the smallest prime number 17 is not the smallest prime number greater than 20, because 17 is not even greater than 20. How about 19? Well, 19 is not the smallest prime number greater than 20, because 19 is not even greater than 20. What is the next prime number? Well, the next prime number is 23, and indeed 23 is the smallest prime number that is greater than 20. And so the answer here is f of 20 is equal to 23, because 23 is the smallest prime number that is greater than 20. Next, we want to figure out what is g of 20. Well, g of 20 just basically means that wherever you see x, you're going to put 20. So we see x here. So g of x is going to be equal to x plus 1 all over 3. So we see x here. So instead of putting x, we're going to put 20. So g of 20 is equal to 20 plus 1. And 20 plus 1 is definitely 21. So we have 21 divided by 3. And 21 divided by 3 is definitely 7. So g of 20 is actually 7. Next, what is fg of 17? What is fg of 17? So what this basically is saying that we have a baby function and we have a parent function. The baby function in this case is g and the parent function is f. So we need to take g and put it inside of f. So what we're going to do is we have to figure out what is g of 17, right? And then when we figure out what is g of 17, then we're going to take that value and we're going to put it inside of the f function. And so let's first figure out what is g of 17. So wherever we see wherever we see x, we put 17. So we have that g of 17 is equal to 17 plus 1 all over 3. And 17 plus 1 is 18. So we have 18 divided by 3. And 18 divided by 3 is definitely 6. So g of 17 is 6. Now we know what g of 17 is. We're going to take g of 17 and we're going to put it inside of our function f. So g of 17 is going to be so that means that fg of 17, so we have fg 17 is going to be what? F of g of 17, okay? So what that means is we have g of 17 inside of our function f, okay? Now what is g of 17? Well, g of 17 is 6. So what we basically have is f of 6. Now what is f of 6? Well, f of 6 is actually a question. F of 6 is telling us, okay, what is the smallest prime number that is greater than 6? And whatever that is, then that's going to be f of 6. And so we have our prime numbers, and they want us to find the smallest prime number greater than 6. 5 is not the smallest prime number greater than 6 because 5 is less than 6. After 5, the next prime number is 7. So 7 is the smallest prime number greater than 6. That means that f of 6 is going to be equal to 7 because 7 is the smallest prime number that is greater than 6. And so f of 6 is equal to 7. And so that means that our answer here is f of 6 is equal to 7. Next, we need to find the inverse of g. And so in order to find the inverse of g, we write g of x is equal to x plus 1 over 3. The first thing that we do is we set g of x equal to y. So we have g of x is equal to y. So we have that y is equal to x plus 1 all over 3. Next, we swap x and y. So we put x over here and y over here. And then we have to solve for y. So we put x over 1, we cross multiply. We have 1 times y plus 1. And we have 3 times x. And so what do we have? Well, 3 times x is definitely 3x. 1 times y plus 1 is y plus 1. Next, we take 1 and we send it over the equal sign. Because remember, we're trying to figure out what is y. So we take 1 and we send it over the equal sign. It was a positive 1. It becomes a negative 1. So we have 3x minus 1 is equal to y. And so we have that y is equal to 3x minus 1. That's what y is equal to. But what exactly is y? Well, y is the inverse of g. And so instead of writing y, we write g inverse. So g inverse of x is equal to 3x minus 1. And so that's what the inverse is. 3x minus 1. The inverse of g is equal to 3x minus 1. And that's the answer to this particular question. Now let's move on to this particular question. This is vectors. And it says, in the diagram, OPQR is a parallelogram, and RX is equal to a third of XQ. Y is the midpoint of PQ. OP is equal to A, and OR is equal to B. Find in terms of AB, the vector PR. So PR means that we start at P, and then we end at R. So we start at P, and we end at R. So this is going to be P to O, and then from O to R. And so what does that mean? That means that we go from P to O, then we go from O to R. That's how we get from P to R. And so what do we have? Well, from P to O is going to be negative A because we're going in the opposite direction of A. Notice that the A is going in this direction, but we're going in the opposite direction. So we have negative A. And then from O to R, it's going to be positive B. So PR is equal to negative A plus B. Next, we have OQ. So we want to find in terms of A and B, OQ. Now, what is OQ? Well, OQ means that we start at O and we end at Q, okay? So OQ, start at O and we end at Q. So that means that we're going to go from here to here and then from there to there. So it's going to be from O to P and then from P to Q. Now, that gives us OQ is equal to A plus B because from O to P, that's A. And then from P to Q, that's B. And the reason why it's B is because this side and this side is a parallelogram. They're parallel to each other. So if this is B, this is also B. And so that means that from P to Q is B. So OQ is equal to A plus B. Next, we have to figure out what is find in terms of x, AB. Find in terms of AB, xy. So, okay. Did I skip anything? I hope I didn't skip anything. Okay, so this is, let's see. This is 2 and this is 3. Okay, good. So we're good. So find in terms of AB, xy. So we need to figure out what is the factor, xy. So in order to figure out what is xy, the first thing that we're going to do is we're going to say, okay, we're going to start at x, and then we're going to end at y. So start at x and end at y. And so the first thing that we're going to do is we're going to say that RQ is equal to RX plus XQ, okay? And that makes sense because notice carefully, if we have, notice that we have RQ, right? RQ. RQ is equal to what? RX plus XQ. That makes sense because RQ, right? This whole thing, RQ is equal to RX, start there, R to X, and then what? XQ, X to Q. Okay, so that makes sense. Okay, so what else do we have, right? Okay, so we know that RQ is equal to RX plus XQ. Next, what else do we know? We know that Rx, right? What do we know about Rx? It says right there, Rx is equal to a third x cubed. That's what Rx is. Rx is equal to a third of x cubed. And so that means that Rq is equal to a third of x cubed plus x cubed. And that's very important because all we did was we substitute Rq, right, for this particular value. So basically we replace Rq with this particular expression, a third x cubed. Okay, so what do we know? We have a third x cubed, right? We have a third x cubed plus x cubed, right? And so what is that? What would that give us, right? So imagine you have a third. So you have a third, right? Plus what? Plus 1. And the reason why I say plus 1 is because x cubed is actually 1 x cubed. So what we have is we have 1/3 plus 1. Or we have 1/3 x cubed plus 1 x cubed. So let's just focus on the numbers in the front. So we have a third plus 1. Now, what is a third plus 1? Well, that's going to be 1/3, right? Plus 3/3. Why is it 3/3? Because 1 is a whole, right? And a whole is 3/3 because 3/3 is still 1. Now, what is 1/3 plus 3/3? Well, that's going to give us 4/3, right? 4/3. And so what does that mean? And why is that important? Well, that means that a third x cubed plus 1 x cubed is actually equal to 4/3 x cubed. So we have that r cubed is equal to 4/3 x cubed. And so let me erase our link. And so what I want to do is I'm going to multiply both sides of this equation by 3/4. And the reason why I'm doing that is because this 3 is going to cancel with this 3. This 4 is going to cancel with that 4. So the 3 is canceled and the 4 cancels. And so that means that I'm left with x cubed is equal to 3/4 r cubed. Okay? And so the reason why I did all that is because I wanted to figure out what is x cubed. And we find out that x cubed is 3/4 r cubed. Now, what does that mean? Well, that means that, let me use a pen. That means that x cubed, the same x cubed right there, the same distance, x cubed is actually equal to the same distance, x cubed is actually equal to 3/4, right? 3/4 r cubed, okay? That's what x cubed is, 3/4 r cubed. Okay, so that's what x cubed is. So that means that x cubed is going to be 3/4 r cubed. So that means that if we look at this whole entire line, if this part is 3/4 of the entire line, r cubed, so if this part is 3/4, then this part right here, must be 1/4. Because then the whole entire line must, if we add them up, it should be equal to 1. So this part is 1/4 r cubed. Okay, so r to x is 1/4 r cubed, and x to q is 3/4 r cubed. Okay, and that's very useful. And the reason why it's useful is because, let me erase our link. It's because when we come here, we know that this whole line right here, OP, we know that OP and RQ, they're the same thing. Both of them are A. So what does that mean? That means that if we have that, we know that OP, because we're looking at a parallelogram, we know that OP is equal to RQ, right? What do I mean? I mean that this line right here and this line right here, they're equal, right? They're equal because we're looking at a parallelogram, they're equal in length. So OP is equal to RQ, which is equal to A, right? Because OP is equal to A. And so so that means that if this whole line right there is A, then that means that this whole line right there must be A, okay? So if XQ is equal to 3/4 RQ, then what does that mean? That means that that means that xq, let me write it down. That means that xq is equal to 3 over 4 a. Okay, 3 over 4 a. Okay, and so let me erase all ink. So what do we have? Well, we have that this xq is 3 over 4a. And if this is 3 over 4a, then rq must be 1 over 4 of a. Okay, so xq is 3 over 4a, and rq is equal to, I'm sorry, xq is equal to 3 over 4a. Again, xq is equal to 3 over 4a, and rx is equal to 1 over 4a. Okay, again, xq is equal to 3 over 4a, and rx is equal to 1 over 4a. And so let's add them up. And so what do we know about x to y? X to y means that you start at x, you end at y. So if we go from x to q, what do we know that is? We know that's what? 3 over 4a, right? And if we go from q to y, well, that's half of b, right? That's half of b, so it's going to be negative 1 over 2b. And the reason why it's negative is because we're going in the opposite direction, and it's half because it's a half of b. So xy is going to be equal to 3 over 4a minus a half b. Next, it says that find in terms of a and b. Oh, that was part A. Now, how about part B? It says xy produced meets OP produced at S such that PS is equal to XQ. Write a simplified expression for XS in terms of AB. Write a simplified expression for XS in terms of AB. And so what we have here is we have XS, right? What is XS? Well, let's look at it. XS is going to be, we start at X, we end at S. So we're going to go from, let's go, highlighter. We start at X, and we're going to end at S. Let me use a different color. Erase all ink. So that means that we start at X, and then we end at S. So that means that we go from X to R, all right? Then we go from R to O. And we're going to go from O to P. And then we're going to go from P to S. All right, and so that's what we have, from X to R, R to O, O to P, P to S, okay? Now, if we go from X to R, we're going in the opposite direction, so it's gonna be negative RX plus RO plus OP plus XQ. And what is negative RX? Well, we know that RX is equal to a half A, so negative RX is gonna be equal to negative, so that means I said that wrong. We know that Rx is equal to a fourth A. So negative Rx is going to be equal to negative 1 over 4A. And so negative Rx is equal to negative 1 over 4A. RO is equal to negative B because we're going in the opposite direction of B. And then OP is equal to A. So we have OP is equal to A right here. And then we have XQ. XQ is equal to, where's XQ? Oh, this is very good. What we did was we substitute PS is equal to XQ, because notice that they said right there, PS is equal to XQ. So in place of PS, we put XQ. That's very important. That's a good substitution. So we know that PS is equal to XQ. So we substitute that here. And then what is XQ? Well, we know XQ is equal to 3 over 4A. So that's what XQ is, 3 over 4A. And so that means that XS is going to be equal to negative 1 over 4A minus B plus A plus 3 over 4A. And so we're going to group all of our like terms together, all of the A's and then all of the B's. And so we have a negative a fourth A plus 1 A plus 3 over 4A minus B. And then when we add them all up, well, first we add a fourth plus 1. That's a fourth. That's negative a fourth plus 1, or negative 1 over 4A plus 1A, and that gives us 3 over 4A. Again, negative 1 over 4A plus 1A is 3 over 4A. And then we have plus 3 over 4A again, and we have the negative B. And then we have 3 over 4a plus 3 over 4a, and that gives us 6 over 4a minus b. We could simplify that some more. So xs is equal to 3 over 2a minus b. And so that's our answer for part B. Next, we have to answer this quadratic equation question. And so what do we have? It says find a and b in the table below for 1 plus 5x minus 2x squared. And so this is a and this is b. So they give us the x value, but we have to find, oh, what is the y value? So here we have to figure, we know that for a, x is equal to 0. And so we have our equation here, and we're going to substitute x for 0. We're going to substitute 0 in for x. So wherever we see x, we're going to put 0. Again, wherever we see x, we're going to put 0. So we put 0 here, we put 0 here. So a is going to be equal to 1 plus 5 times 0 minus 2, 0 squared. Now, 2 times 0 squared is 0. 5 times 0 is 0. So a is equal to 1 plus 0 minus 0. That means that a is equal to 1. Next, we have x is equal to 3. And so, because for b, right, we have to figure out the value for b. And so in this case, x is equal to 3. So we substitute 3 into this equation. So we have that 1 plus 5 times 3 minus 2 times 3 squared. And then we have 3 squared is equal to 9, right? And 5 times 3 is equal to 15. And next, what do we do here? We say 1 plus 15 minus 2 times 9, and that gives us negative 2. So b is equal to negative 2. So a is equal to 1, and b is equal to negative 2. Next, what do they want us to do? They said using a scale of 2 centimeters to 1 unit on the x-axis for negative 2 is less than or equal to x is less than or equal to 4, which basically means that x is going to be in between negative 2 and 4, but we include negative 2 and 4, and 1 centimeter to 1 unit on the y-axis for y is greater than or equal to negative 4, and y is less than or equal to, for y is greater than or equal to negative 7, and y is less than or equal to 7. Draw and label the graph of y is equal to 1 plus 5x minus 2x squared. And so that's what we have to do. We have to actually graph this and plot these points on the diagram, on the graph. And so we know that a is equal to 1, and we know that b is equal to negative 2. And so here we have our graph. Remember, let's just first focus on the x-axis and the y-axis. So for the x-axis, they said that we are going to go what? 2 centimeters is 1 unit. So what does that mean? That means that if we have 0, we're going to go 1, 2, that's 1 unit. We're going to go 1, 2, that's the next unit. We're going to go 1, 2, that's the next unit. We're going to go 1, 2, that's the next unit. That's what they mean by 2 centimeters to 1 unit. But we have to start from negative 2, and we have to end at positive 4. And so notice here, I start at negative 2, 1, 2, negative 1, 1, 2, 0, and I go on all the way up to positive 4. So negative 2 to positive 4 on the x-axis. Make sure I label that. Next, they said that they want on the y-axis 1 centimeter to 1 unit, and you're going to go from negative 7 to 7. And so we go from negative 7 to negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, all the way up to 7 on the y-axis. And it's 1 centimeter to 1 unit, which means that each block is one unit. So 1, 2, 3, 4, and so on. Okay, so now that we have our x and y axis, we have to draw and label the graph. So that means that we have to plot these particular points. And so let's plot the points. Our first point is negative 1, negative 6. So that's negative 1, negative 6. Next point is negative 0.5 and 2. So this is negative 0.5 and 2. The next point is 0, 1. So this is 0, 1. The next point is 0.53. So this is 0.53. Next point is 1, 4. It's going to be 1 and 4. Next point is 1.5 and 4. This is 1.5 and 4. Next point is 2, 3. So it's going to be 2, 3. Next point is 2.51. This is 2.5 and 1. And then next point is 3 and negative 2. So 3 and negative 2. And then the last point is 3.5 and negative 6. So it's going to be 3.5 and negative 6 here. Now that we have plotted the points, this is a curve. This is actually a parabola. And so we draw the parabola and we have to label it. And we label it y is equal to 1 plus 5x minus 2x squared. And so we finish with that part. Next, it says use your graph to solve the equation negative 3 is equal to 1 plus 5x minus 2x squared. And so we have negative 3 is equal to 1 plus 5x minus 2x squared. Now, this right here is our parabola, right? That's our parabola. And this right here is negative 3. And so what we have here is we have two graphs, basically. We have the graph of y is equal to negative 3. And we have the graph of our parabola, y is equal to 1 plus 5x minus 2x squared. And where these two graphs intersect, that's going to be the solution for this particular equation, where these two graphs meet, right? And so the solution to the equation are the x coordinates of the points where the graphs of y is equal to 1 plus 5x minus 2x squared and y is equal to negative 3 intersect. So we have to figure where these two graphs intersect, and that's going to be our solution. The x coordinates are going to be our solution to our question. So let's do that. So here we draw the line y is equal to negative 3. That's going to be a horizontal line that runs through negative 3 on the y-axis. And then if we notice carefully, there are 2 points where this graph in red intersects our parabola. It intersects the parabola at this point, the point 0.4 comma negative 3, and the point 3.14 comma negative 3. And so that means that, remember, our solution to our equation is going to be the x coordinates. And so that means that our solution is going to be, the solution to this equation is going to be, so I have using the graph, we found out that the two graphs intersects at negative 0.64 and negative 3 and 3.4 comma negative 3. Therefore, the solution to this equation that they gave us is x is equal to negative 0.64 and x is equal to 3.14, correct to 2 decimal places. All right, next, they want us to find the gradient to the curve y is equal to 1 plus 5x minus 2x squared at the point 1, 4. So in order to find the gradient of this particular equation or of this particular curve, we have to find the derivative of this particular equation. In order to find the derivative of it, we're going to use the power rule, all right? And so what the power rule basically says is that if you have x to the power of n, all you need to do is you need to take, let me just show you what I mean by the power rule. All you need to do is you need to take, all you need to do is you need to take n and multiply it by x. So bring it down here, multiply it by x, and then raise x to the power of n minus 1. So basically, if you have x cubed, right, and you're trying to find the derivative of this, you would bring x down. You bring 3 down, and you would say, okay, 3 multiplied by x to the power of 3 minus 1. What is 3 minus 1? 3 minus 1 is 2. So it's going to be 3x squared. Okay. So the derivative of 3x, so that means that the derivative of x cubed using the power rule is going to be 3x squared. That's the derivative. So you have x cubed, and to find the derivative of this using the power rule, we're going to bring down the 3. So we have 3, and then we're going to raise it to the power of 3 minus 1. So it's going to be 3 minus 1, which is 2. So this is 3x raised to the power of x squared. So 3x raised to the power of 2. That's what I should say, 3x squared. Okay, so that's basically how to use the power rule. And so the derivative of a constant is 0. If we have the derivative of 5x, the derivative of 5x is just 5. If we have the derivative of 6x, the derivative of 6x is 6, the derivative of 7x is 7, derivative of 8x is 8, and so on. Now, for this particular term, we use the power rule. So we say 2, so we take the 2, and we multiply it by, we bring it down. We take the 2, we multiply it by this 2, that gives us this 4. And then we take x and we raise it to the power of 2 minus 1. So that's why we have 2 minus 1 now. Again, we take the 2, we bring it down. But when we bring it down, we have to multiply it by the 2 that's already there. So we say 2 times 2, which gives us 4. Then we take x and we raise it to the power of 2 minus 1. Now, what is 2 minus 1? Well, 2 minus 1 is simply 1. And so we have 0 plus 5, which is still 5. And we have negative 4x raised to the power of 1, which is just going to be 4x. All right, negative 4x. And so the derivative of y is equal to 1 plus 5x minus 2x squared is equal to 5 minus 4x. Now we need to evaluate this derivative at the particular point x is equal to 1, because that's what they tell us, right? The point 1, 4. And so we're going to substitute 1 into this equation. And so that means that we have 5 minus 4 times 1. And 4 times 1 is simply 1. So we have 5 minus 1 and 5 minus 1. I'm sorry. What we actually have is, let me do this again. We have to replace x with 1. In this particular equation, we're going to replace x with 1. So wherever we see x, we're going to put 1. And so we have 4 times 1. So we have 5 minus 4 times 1. And so we have 4 times 1. What is 4 times 1? 4 times 1 is 4. And so we have 5 minus 4, and 5 minus 4 is definitely 1. So that means that the derivative evaluated at x is equal to 1 is going to be equal to 1, which means that the gradient of the tangent to the curve is actually equal to 1. So the slope is 1. So therefore, the gradient of the tangent to the curve, y is equal to 1 plus 5x minus 2x squared at the point 1, 4 is 1. Okay, that's great. Next, we need to draw the tangent to the curve. Y is equal to 1 plus 5x minus 2x squared at the point 1, 4. Now, the good thing is we have two things. We have the slope, which is 1, and we have a point, which is 1, 4. And if you have a point and a slope, you could graph a line. And so let's graph this tangent line. Again, remember, we have the slope and we have a point. So what's the point? The point is, the point is 1, 4. Where's 1, 4? This is 1, 4. So this is the point right there. That's on this line. And what's the slope? The slope is 1. And what does that slope of 1 means? Right? Slope of 1 means that 1, if you have a slope of 1, that means that you have 1 over 1, because 1 over 1 is still 1, right? That means that your rise is 1, right? That means that your rise is 1. And that means that your run is 1 as well. Okay? So your rise is 1 and your run is 1 as well. And so let's use a highlighter. So let's use the yellow. And so we start at this particular point right here. And then we're going to go down 1. So we're going to go down 1. And we're going to go to the right, sorry, to the left 1. And this is another point. And we're going to go down 1. We're going to go to the left 1. That's another point. Then we go down 1. We go to this point 1. We go down 1. We go to the left 1, right? Similarly, we go to the right 1. We go up 1. We go to the right 1. We go up 1. We go to the right 1. We go up 1. We go to the right 1. We go up 1. We go to the right 1. We go to up 1. And then we just draw a line that intersects all of these. And that's going to be the green line that we have drawn. And that's our tangent line. And so that's how we figure out our tangent line using just a point and a slope. And so this is going to be our graph. Now, what do they say? What do they want us to figure out? Well, that's the last question. Okay, so that's the end. So all they wanted us to do was to draw the tangent. And so we already did that in the green line. All right. And so this right here is the answer to this particular question. Thank you for watching. and I'll see you in the next video.